In this video, we're going to learn about scatter plots and correlations, and you've probably seen a scatter plot before, but we're just going to dig a little deeper than you have in the past. So your objective is that you can create a scatter plot, and I can find and interpret the correlation and determine where the line of regression of a scatter plot is. So these are examples of scatter plots. Now in the past you've only did one type of scatter plot, and we're actually going to do two different kinds of scatter plots, and eventually in the year we'll add a third one. So a scatter plot is just a set of plotted points that shows the relationship between two data sets. So on this first scatter plot, it's showing the relationship between the weight and the height of people. And then notice these points represent people's data. Here we're doing the in lab and then in field crack size, so it's talking about some science, measuring things, and then this shows the relationship. Whoop. Where's that? My pen is super sensitive for some reason. Alright, and then here's an example of another scatter plot. Now all three of these are kind of linear scatter plots where you can draw a line through, and we'll talk about what that line is on the next slide. But then notice this scatter plot, it kind of curves, and if we just got done last unit, this is more of an exponential, and we're going to talk a little deeper about that in the next few slides. So notice the scatter plots can go upwards and they can also go downwards. Alright, so the line or curve best fit. You have done the line of fit probably in the past, but we're also doing a curve. A line is a line or exponential curve that can be drawn to fit the data set. So when the points kind of make a line, this is the line of best fit. So there's a line, which should be straight, that you can draw through that goes through most of the data set that is really close. Where this one is an exponential curve. Notice the points slowly go up. So this one would actually look like an exponential graph that we did in Unit 4. Okay. So the point of scatter plots is that there's some line or some curve that fits the data set that can be drawn, and we use this line to predict. And we'll be doing that more in class when we do the work. So there are types of scatter plots. So there's a linear relationship. And when there's a linear relationship, it could be positive or it could be negative. And that's referring to the slope. So a positive scatter plot would look something like this, where the points are going upwards. A negative looks something like that. Now with exponential, we have growth or we have decay. And those points, again, they're not going to be in a straight curve, but you can see that they kind of curve out. Oh, I just realized I just did decay, so let's make that correct. So growth would be like this, going upwards. So notice it curves where these are kind of more straight. And then let me draw the decay. So it kind of curves out. And again, you could draw a line in each of these. Line going up, line going down, and then these are curves. Exponential. Like so. Alright, so correlation is super important when doing scatter plots because they tell you how strong the relationship between the two data sets. We want to know if something has a correlation, which if they have a correlation, they mean they relate to each other. Mean one affects the other per se. So let me look at the different types of correlation. So correlation has an R value. So we're going to be looking at different R values to know how strong the correlation. Now, if it has a -1 or a 1 R value, notice they say perfect. We want, if there is a the strongest relationship we can have, just doesn't want to, the pen is just driving me nuts, sorry. Negative relationship, if it is perfect, alright, let me pause the video and alright, so I'm back. Hopefully my issues are gone away. So then we have perfect correlation, positive and negative. This means if it has a perfect negative correlation, the dots are in exact line. Okay? Not one of them is off the line. All right? If it was exponential, whoop, erase that. Still having issues. That means it is a perfect exponential curve. And then if a perfect positive correlation means it's going upwards in a perfect line. And then this would be an exponential curve like so. All right? So in other words, if I would draw a line on these, every dot is on the line. I can do one here too. I drew the line straight. There you go. Every dot is on the line. And then if I had an exponential curve, every one of those points are on the line. So then let's look at no correlation. No correlation just means the dots are everywhere. There is no rhyme and reason as such. They're all over the place. So that correlation would be 0. So in other words, the closer you are to 0, the worse your correlation is. It does not, positive, negative just tells you about the directions of the dots. And then so if you have something in the middle, like a linear one, it'd be something like this. You can kind of see a line, but they're still a little bit all over. And then same with the exponential. Kind of what I showed you on the previous slides. You can see that it's an exponential relationship, but they're not a perfect exponential curve. And then this one would look like here for positive, if it was in between, and then this would be something like that. Okay? So in other words, when it's 1 or negative 1, that means it's perfect. It's good. If it's 0 correlation, that means the two things do not rate at all. Alright, so to review, scatter plots, there are two types of scatter plots. We have linear scatter plots, which make a line. We have exponential scatter plots, which does the exponential curve. The correlation ranges from -1 to 1. 0 means there's absolutely no correlation. Because we'll be looking at different R values and we'll be finding R values for scatter plots. So notice in class we're going to learn how to create and interpret scatter plots. I just want you to become familiar with the vocab and the correlation. Reminder to do a reflection so you get credit for watching this video.